Right, so today we'll finish up section 6.3, which will end everything we're going to be looking at in depth with sine and cosine. And tomorrow we'll look at 6.4, which looks at the tangent, the cotangent, the secant, and the cosecant, all what those look like. Tomorrow the focus isn't going to be quite as much graphing by hand. It's going to be more like identifying things about the graph. Kind of like we did with sine and cosine. Like what's the period, what's the amplitude? I'm going to ask more questions like that. It'll be a little sketchy, but not as much. So when we graph multiple transformations, there's a certain order we have to follow. Now, in the notes, when I did all the transformations, I used the letters A, B, C, and D. So as we went through them Monday and Tuesday, I was pretty much giving you this order. So out of the 4 transformations we studied, vertical shift, phase shift, period change, amplitude change. What's the first one you would always do if you had multiple ones? Jake?
Phase.
Yeah, first one you always do is a phase shift. When I gave you that one on Monday, I used the letter A. It was like x plus or minus A. So that A was there to tell you it's the first one. What transformation did we do that had the letter B in it? I hope I didn't do B for vertical. If I did, that would not be good. I think I used a different letter for vertical. Yeah?
Period change.
Period change. So the ones we did yesterday, the letter I used for B was with period change. So both of these affect your horizontal. Shift left and right, stretch left and right. So that's horizontal. Both of these are going to be the vertical. So the next one we're trying to find what transformation used the letter C. Jake?
I don't know what it's called. It's one that goes up and down.
Well, there's 2 that go up and down.
It's the shift.
It's the other one that goes up and down.
Yeah, change.
The amplitude change, or vertical stretch. It's that one. So what does that leave for the 4th transformation? The vertical shift. Okay, so that's the order that you want to follow if you have multiple transformations. Now, what else can happen? I think we did look at this yesterday. Like if you have a negative, what can that cause the graph to do? Flip or reflect. There's 2 ways it can flip and reflect. It can reflect horizontally, it can reflect vertically. If you had a reflection, you can do it right after the stretches. Okay, so if you had a reflection, if it applied, you could do it right after step 2. And then if you had a vertical reflection, you could do it right after step 3. If it applied. Okay. Any questions on that order? Now, if you stick with that order, and you do it correctly, you'll always get it right. There are times you can go out of order, but you have to know what you're doing and do it carefully. Otherwise, you're going to make a mistake. So my advice would be just stick with that order. Okay, let's look at this one. All right, first thing I want to figure out is just how many transformations are happening. So Greta, if we look at that one, 2 sine x plus pi over 2, how many transformations am I doing?
2.
2. Connor, can you tell me one of them?
You're going to have to stretch it by 2.
So what kind of stretch?
Be horizontal.
Nope, not a horizontal.
Vertical.
Vertical. Remember when the number's outside, that's a vertical. So we're going to do a vertical stretch. And what else? Scott? Yeah, sure.
You're going to do a horizontal shift.
Yep, we're going to do a horizontal shift and we'll have to figure out if it's left or right, but we're going to do a horizontal shift. All right. Out of those two, vertical stretch and then the horizontal or the phase shift, which one do I do first?
Phase shift.
Yep, I'm going to do the phase shift. So what I'm going to do for now is I'm going to forget about the 2 in front, and I'm just going to do this problem. Sine of x plus pi over 2. Okay, and I'm just going to move this down. Okay, so that's phase shift. Kylie, what values stay the same when you do a phase shift? The y's. Okay, phase shift is going to move it left and right. So the x's are going to change. So I need my y's for sine. Megan, what are my y values for sine?
1, 0, -1.
Let's go sine.
Oh. What is it? 0, 1, 0, -1, 0.
0, yeah. So those are your y values for sine. I'm not saying they're the final answer, but they're the numbers we're going to use at this step. All right. Now we're going to take all of the original x's. And Rebecca, what are my original x values?
0, pi over 2, pi, 3 pi over 2, 2 pi.
All right. And we got to do something to all of those. Alec, what am I going to do to all those x values?
Are you going to add pi over 2 to them? Or no, subtract pi over 2 to them?
Subtract it,
Opposite,
yeah. When it's inside, it's the opposite of what you would expect. So we're going to subtract pi over 2 from all of them. Out of the 2 transformations in this problem, this one's the harder one, okay? Because you got to deal with pi. All right. First one, that's not that bad. Emily, what's 0 minus pi over 2?
Negative pi over 2.
Yeah, it's just negative pi over 2. The next one, pi over 2 minus pi over 2. 0. Now the next one, we would need a common denominator. Sam, what's the common denominator between 1 and 2?
1.
Well, common
or
denominator has to be bigger than all
Oh,
the
yeah,
others.
2.
Yeah, 2. How would you make a common denominator of 2 here?
Multiply the top and bottom by 2.
Yep. What's 2 pi over 2? Take away 1 pi over 2. How about Madison? 2 pi over 2 minus 1 pi over 2. Pi over 2. And then the next one already has a common denominator. That's 3 pi over 2 minus 1 pi over 2. So that's 2 pi over 2. Now, let's look at the pattern. Negative 1 pi over 2, 0 pi over 2, 1 pi over 2, 2 pi over 2. What would the next one be?
3 pi over 2.
Yeah, based on the pattern. So that's the first part. We've done our phase shift. Now, we still have to deal with the 2. Okay. What did we say that the 2 is going to do? Chat?
A vertical stretch.
It's a vertical stretch. And what values does that affect?
The y.
The y's. So now we're going to make another table. But for this table, we're not going to copy something back from the original table you had on Monday. We're going to copy down something that we have in this table here. We're going to copy the x's because the x's have been shifted. So copy down your x values from that table. So negative pi over 2, 0, pi over 2, pi, 3 pi over 2. Now, the original y's, I don't need to write them because I already have them right here. Emily, what do I do with all the y values? Yeah.
the reciprocal?
Not when it's on the outside. When it's on the outside, you just use it the way it is.
Okay.
So we're just going to multiply everything by 2. So 0, 2, 0, negative 2, 0. Yeah. And that's your table. That's how you do multiple transformations. You just do, it's like doing 2 problems back to back. Any questions on how we get the x's or the y's there? Okay, and now we graph it. Now, before I graph it, look at the x column. Is there a coordinate that has an x value of 0?
Yeah.
Yes, then I'm not skipping 0. Because I'm not skipping it, I'm not going to have to skip anywhere. Right? If I was missing 0, like in the middle somewhere, like for the second, the third, or the fourth coordinate, if there was no 0, then I know I'm skipping it. And then I'd have to skip every time. Okay, but no skipping here. It's a non-skipping zone. All right. No skipping. So negative pi over 2, 0, pi over 2, pi, 3 pi over 2. Those are all nicely spaced. That's negative 90, 0, positive 90, positive 180, positive 270. So they're all 90 apart. And now as far as the highest and the lowest, let's just scale it to go by 2's. Okay, and now plot your points. So negative pi over 2, 0, 0, 2, pi over 2, back down to 0, negative 2, and 0. And just connect your points. And there's your sketch. So it's been, you can see it's been shifted a little bit to the left, because here's your axis right there. So it's been shifted a little bit left, and it's been stretched vertically by a factor of 2, which you can't really see because we scaled it. Okay. So on the test, all I would be grading on this problem is the final table and the final graph. If you don't want to do the table in the middle, that's fine, but I got to see the final table.
On the test, is there a question where we have to use all of these like steps of phase shift, period change, amplitude change, and vertical shift?
No, not all 4 in the same problem. I think the worst case would be 3 in the same problem.
All right.
But like, actually, I didn't do any with 3. So you know what? I'll probably just stick with 2. So at most, you'd have 2 in one problem. Yeah. Okay, let's look at this one. 3 cosine 2x. Okay, 2 transformations again. The 3 is going to do something. The 2 is going to do something else. Nate, can you tell me what each number there does?
Well, 3 is going to be doing a vertical stretch.
Which number?
3.
3, yeah.
And the 2 that's going to be a period. The 2 is a period change.
Correct. Specifically, the 2 is going to actually cause the graph to compress. Yep.
Press.
Does the opposite. It's a big number. It's not that big, but it's bigger than 1. Bigger numbers make the graph small horizontally. How about Kat? Which transformation do we do first? The period change or vertical stretch?
The vertical stretch.
Let's go back and look.
Just kidding, period change.
Period change. So period change, always do that before vertical stretch. All right, so let's do it. So for now, I'm going to pretend the problem is just cosine 2x. I'll come back and make another table, and I'll do the 3. If I wanted, I could do both at the same time, but usually confuses people when I do that. All right, so period change. Alec, what is going to be the same? When you do a period change, these values aren't affected.
The y values.
The y values. So I need my y values for cosine. Isabel, what are my y values for cosine?
1, 0, -1,
So we got our y values. And now I'm going to put my original cosine values off to the side. Pi over 2, pi, 3 pi over 2, 2 pi. And this one is where you have a couple choices, how you think about doing it. So Isaac, what's one way I can get my new x values?
Can divide by 2.
Yep, you can divide everything by 2.
Or multiply by a half.
Or multiply by a half. I think it's easier to think of multiplying by a half here, so we don't end up with like pi over 2 over 2. It's kind of weird. So let's take half of all these. Nick, what's half of 0?
0.
Yeah, it's 0. And Jaden, half of pi over 2? You're just going to multiply by 1/2 and then go straight across. So pi over 4. And Jake, what's half of pi? Yeah, it's not really a lot we can do with that one. Half of 3 pi over 4. About Emily?
3 pi
Yeah, never mind. What's half of 3 pi over 2?
3 pi
Yeah. And half of 2 pi, Michael?
2 pi is pi.
Yeah. Doesn't look like there's a pattern there, but if you wrote everything with a denominator of 4, 0 pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. So there's a nice pattern. So they're all equally spaced. Is there an x value that has a coordinate of 0? Then I'm not skipping it. Yep. So I got 0, 1 pi over 4, 2 pi over 4, but reduce it.
We don't need to do the other part?
Yeah, these values are okay. I can write them down now, but yeah, you're right. I still need to finish it, but I'm done with the x's. So the x's aren't going to change. The y's are going to change, but I probably would have forgot that. So thank you. So 3 pi over 4 and pi. I'm going to hold off on labeling my y's for now because I don't know what they are yet. So now, as Jaden said, let's do the other part. The 3 is in front. So we already said, or Nate said earlier, the 3 is a vertical stretch. That means the x's, x's are all done. Those aren't changing. All right, so we got the x's. Now, what am I going to do to get my new y's? By 3. So we're going to triple the old ones. 3, 0, negative 3, 0, 3. I mean, I just kind of went through that fast, but is there any question on how I got 3, 0, negative 3, 0, 3? Okay, so now we've got our table. X's I already set up. Y's, let's set those up. Again, I'm going to scale it so it doesn't take up a lot of space. Okay, and let's see what we got. So 0, 3. We're back to 0. Pi over 2, it's negative 3. Let's see, 0. Back to 3. Okay. Any questions on those points? And now what's the last step? Yeah, actually draw your line, draw your curve through those points. So we did a multiple transformation where we had a period change and a vertical stretch. We did a phase shift and a vertical stretch. Let's do one a little different. Let's do I don't want to do another phase shift. Let's do a vertical shift because we haven't done that yet. So we'll do a vertical shift combined with a vertical stretch. Now, if if you look back at the problems we've done, this one's a little different. Not just because of the transformations, but look at which values they affect. One of them affected the x values. The 3 affected the y values. In this one, the phase shift affected the x values. 2 affected the y values. Look at this one. That's a vertical shift and a vertical stretch. They both affect which values? Y. This is where the order is very important to follow. Technically, remember I said you could go out of order and sometimes you're okay? On example 2 and 1, you'd be okay. The only reason you'd be okay is because one transformation changed x, one changed y. They're totally separate. On this one, they both change y. If you go out of order, it's wrong. And if you're not sure why, think of a number in your head, multiply it by 5, and then add 3. Take that same number, but do it in the other way. Add 3 first, and then multiply by 5. You don't get the same answer. Okay. So what's nice here is we're going to change the y values, which means the x's, the ones we don't really like, stay the same. So yeah.
If there was a number in front of that x, it would change the x's, correct?
Then the x's would change too. Yeah. You would multiply by the reciprocal of that number. Yep. So what are my x values going to be for this whole problem?
0.
Yep.
Pi over 2. Pi, 3 pi over 2, and 2 pi.
Okay. Now let's see if we can do it in one step instead of making 2 tables. So which one? I'm going to take my original y's, which are 0, 1, 0, negative 1, 0. And what am I going to do to the y value first? And this is where the order is important. Jade?
Add 3.
So what is that add 3? What's the name of that transformation?
The vertical shift.
I agree, that's a vertical shift. When do you do vertical shift?
After. Just kidding.
After.
You're going to do the other one.
So vertical stretch comes first. How do you do the vertical stretch? What's like the arithmetic I need to do? Times 5, and then how do I do the vertical shift? After I do the times 5,
Plus 3.
do a plus 3. So let's take 0 times 5 plus 3. Rebecca, what would that be?
3.
3. Okay. Greta, how about the next one?
8.
Yep, that would be 8. The next one we already have from up above. The next one, negative 1 times 5 plus 3. Negative 2. And 0 we already have. So the numbers look a little weird, but if we graph them, it should come out okay. My y-axis, I'm going to go by 2's, because I don't have enough room to go by 1's. So 0, 2, 4, 6, 8. And for my x's, we didn't skip 0, so you don't need to skip. So 0, pi over 2, pi, 3 pi over 2, 2 pi. And in fact, if I want, I can move those labels up close because the graph is going to be up higher. Okay, let's see what it looks like. So we've got 0, 3. Since I'm going by 2's, I'm going to be in between lines, but it's not a huge deal. Pi over 2, we're at 8. Pi, back at 3. I did move my labels up a little too far. Let's put them right there. You can move them up, but not as far as I did. 3 pi over 2, we're at negative 2. So you know what? I'm going to draw in one more. So 3 pi over 2, negative 2, and 2 pi 3. Back at 3. So with the exception of me having to draw that in, that looks a little off because I didn't draw it pretty good. But that's what the graph should look like. Okay, what's the amplitude of that graph?
5.
Yep.
5.
5, yes. And there's a difference between the maximum value and the amplitude. What's the maximum value in this problem? Sam?
8.
8. So the highest value it ever hits is 8, but the amplitude would be, if you put a line in right there, measure the distance from the center line to the highest point. So 3 to 8, that's 5. Okay. What about the period? What's the period of that one? Well, did we do a period change? We did not. So what's the normal period if you don't change it? 2 pi. Yep. So the period of that is 2 pi. Okay. Remember, the formula to find it is 2 pi divided by b, where b is the number in front of x. In this case, it's a 1. Okay. Any questions on that? Right. So on the test, you'll have, when we graph, one of each individually, and then one problem where I picked 2 transformations in the same problem. Any 2. All right. So as far as sketching by hand, that's kind of that part. Now we're going to do some sketching on the calculator. So they want me to graph 4 sine 3x and find out some things about it. The things that I'm asking you to find here, this is more like the problems tomorrow. There's a little bit of graphing tomorrow, but it's mostly this kind of stuff. All right. So let's write these down. Kind of figure them out as we go. Domain. That's how far left and right the graph goes. If you graph sine or cosine, how far left and right do they go? Yeah. Yeah, for forever. So we can say negative infinity to infinity. Every sine and cosine function, that is the domain. If you shift it left or right, and it goes on forever, well, it still goes on forever, even if you shift it. Range. Let's think of this normal sine function. How high and low does the normal sine function go? 1 to 1. Negative 1 to 1. Have you done anything here that would affect y values? Yeah, what have you done?
The 4.
Yeah, 4. Yeah, you've stretched it out by a factor of 4. So it's not going to be negative 1 to 1. It's going to be negative 4 to 4. That's your range. Amplitude. Sometimes the amplitude and the maximum value are the same. Sometimes they're different. In the last problem, they were different. In this problem, they're the same. What's the amplitude? 4. Yep. And period. What would be the period of this one? 2 pi divided by 3. Yep. Any questions on how we got any of those? Yeah.
The period one, why?
So remember the formula for period, if you're doing sine and cosine. We'll talk about the other ones tomorrow.
Oh, you have to use the T formula?
Yep.
Okay.
That's how you find the period. Right. So that's the hard part. Now the easy part is to graph it. So type in 4 sine 3x. And for my range, I'm going to go negative 5 to 5, just so it's not right on the edge of the screen. And how big was one period in this problem? 2 pi over 3. So what that means is you have to set a window if you want to see one period from this edge to this edge of the window. It has to be a distance of 2 pi over 3. There's a lot of ways to do that. It's kind of like if I said to you, I want you to make a window with a width of 5. Well, you could go 0 to 5. You could go 2 to 7. You could go negative 3 to 2. All those numbers I said have a width of 5. Right? So we just got to set a width of 2 pi over 3.
Why don't you 360.
Yeah, if you wanted to think of this in degrees, that's a period of 120 degrees. We're going to do it in radians. But yeah, you're basically setting a window that's 120 degrees wide from min to max. So what would be the simplest way to get a window that's 2 pi over 3 units wide from min to max? And I want to put that in on the x's. So I put that in the wrong spot. What could I set my x min at? Oh, Connor? Any thought?
I would say a little bit before and a little bit after 2 pi over 3, but that's not the exact one.
Yeah, I want like an exact number. Like tell me, set your x min at
Would it be
this.
2 pi over 3?
You could. Yeah, you could if you wanted. I think there's an easier way to do it, but it's kind of like if I said make a window 5 units wide. You could start at 5 and go to 10. 5 to 10 is 5 units wide. You could also start here and go here, and it would be a little easier. Yeah?
0.
Yeah. Is that what you were going to say? 0? Yeah. So if we start at 0 and we go to 2 pi over 3, you've just created a window that's 1 cycle wide, and you'll see exactly 1 cycle. Let me just speed it up a little. Now, what if they wanted to see a graph that was 2 cycles wide? If 1 period is 2 pi over 3, how big would 2 periods be? It would be 4 pi over 3. So now, create a window that's 4 pi over 3 units wide. There's a lot of ways to do it. 0 to 4 pi over 3 is the simplest way to do it.
Can you show me where you put into the calculator? Because mine's being computed.
Yeah. Does everyone see how I just got 2 cycles though? 2 full cycles? Again, make sure you're in radians too.
There's purple dots on my graph. How do I take those off?
Is one of these lit up? Plot 1, plot 2, or plot 3?
Yeah.
So just go up to it, and once it's highlighted, just hit enter. And that should get rid of the chicken pox.
There we go.
All set?
How do I set it on?
Okay. Other questions on that? Like how to set anything, how to adjust anything?
So why is mine like this?
Right, let's do
Oh, does it?
one more with this. What if they wanted to see 3 cycles on the screen? How wide would your screen have to be now?
6 pi over 3.
6 pi over 3. You would triple that. And what's 6 pi over 3?
2 pi.
2 pi. Now, I'm going to show you this one a couple different ways. Does everyone agree 0 to 2 pi is a difference of 2 pi? All right. So that's one way I could do it. I could also go negative pi to what? Negative pi to what would be 2 pi?
2 pi over 3.
So we're trying to get a window that's 2 pi units wide. If that's at negative pi, the left edge, what would the right edge have to be? Pi. From negative pi to pi is another way to get something that's 6.28 units wide. And if you graph it, you'll see exactly 3 cycles again. Perfect. 3 cycles. Doesn't matter, like if I ask you on the test to show me 3 cycles or show me 2 cycles, doesn't matter where you show me them. You can show me them anywhere you want. I just want to see 3 cycles somehow. All right, let's do this one. Same idea. Domain, that's the easiest thing to start with. It never changes. What's the domain for every sine and cosine function? It's always negative infinity to infinity.
Wait.
Yes.
Morgan's calculator is doing something funky.
It keeps saying there's a syntax error.
A syntax error?
It like graphs it all the way through.
Let me take a
and then
look.
syntax error.
All right, so the domain is negative infinity to infinity. Let's look at the range. What's the normal range for sine? What to what? Yeah?
1 to negative 1.
Negative 1 to 1. And now what have we done to the range here? We've tripled it. So what's negative 1 to 1 tripled?
3 to negative.
Negative 3 to 3. That's kind of helpful because now when I set my window on my calculator, I got to make sure it's at least that big. If I go smaller, I'm going to cut it off. Period. Yeah, there's been no change to the period at all. No period change. So the period is 2 pi, which means if I want to see one cycle on the screen, I've got to set it 2 pi units wide. And amplitude. Okay, what's the amplitude? 3. All right, so now let's graph it and see what it looks like. 3 sine x minus 1. So 3 sine x minus 1. All right, so I wanted to see, let's just do one cycle. So if I want to do one cycle, I could go from 0 to what? Yeah, 2 pi. We'll just do that. Now remember, it's been phase shifted a little bit, but that is definitely one cycle. The way I could also tell is if I did this. Put this here, trace that section, just like that. Now, if that's truly one cycle, I should be able to copy and paste it, and it should look like a perfect wave, and it should meet up right where the other one ends. So that's one cycle. It is kind of in the middle of the cycle. Usually we like to do it like this. That's a nicer way to show one cycle, but that works too. That's fine. Questions on that one? All right, so last thing we're going to look at, this is the last thing we're going to look at tomorrow as well, is how you solve a trig equation by graphing it on the calculator. All right. So whenever we graph two things on the calculator and we want to solve it, we have to calculate what? Does anyone remember?
Say that again?
Whenever we graph two things, like something in y1, something in y2, we draw it. And if we want to find out where they're equal, there's a feature. Intersect. Yeah. So we're going to calculate an intersect. So put sine of x, put 0.4. And now they're telling me the window. They're saying x is between 0 and 2 pi. So that's what I have to do. I don't have any choice this time. I already have that in there. So 0 to 2 pi. Now, this is just the basic sine function. So it's only going to go negative 1 to 1. If I keep it set at negative 5 to 5, it's OK. You're still going to be able to see it. But I would like to zoom in a little. Okay. So I've set up my window. I've got everything typed in. Let's hit graph. So there's the sine function. And there's my line. Y 0.4 is just a line at 0.4. How many times do they cross? They cross twice. So let's go second calc, intersect. If you just hit enter a bunch of times, it'll give you one of them randomly, whichever one you're closer to. So 2.73. That's one of our answers. And now to get the other one, second calc, intersect. Go over to here and do it again. 0.41. 0.41. Now, on the homework, I think they say to find these answers two different ways. You don't have to find them two different ways. All you have to do is what we just did. When they say two ways, they're talking about doing it using algebra. I can use algebra. If I go like this, you can see it's not that hard. I just got one of the answers, 0.41. And I didn't even have to type that much stuff in to do it. But we're not learning that yet. Okay, so for now, you just have to graph it. Okay? Don't worry when it says to do it 2 different ways. Now, why did they tell me between 0 and 2 pi? Like, are there going to be more answers?
Oh, there's no
Yeah.
answers.
Yeah. Like if I set this bigger, like if I go all the way to 25, you're going to have a wave, and you're going to have a horizontal line that keeps hitting it over and over. Well, it hits these points very regularly. Every single cycle, you're going to get 2 answers in the upper part of the wave. So you get 2 in this cycle, 2 in this cycle, this cycle, this cycle. Eventually, we're going to want to describe all those answers. Once you know any 2 of them, it's very easy. But for today, all you have to do is write 2 of them. Don't worry about the other ones yet. But that's it for today. These are all kind of the same. Let's do that one. All right, let's try this one. Notice when they write the interval for the window, it says 0, less than or equal, and then the other one is just a less than. I did that here, I did it here, and I did it here. It's not a mistake, that's intentional. Because usually if you include one edge of the window, 0's right on the edge, you don't include the other edge, because that's a repeat. The left edge is the same as the right edge in the next cycle. If that makes sense. Oh yeah, go ahead in there. Do you need anyone to go with you? No. No? Okay. Let me get to go. Yeah, you're welcome. All right, so let's graph it and see what it looks like and go from there. So 2 cosine 1/2 x. It's easier to type 0.5, so I'm going to do it that way. And 1.5. If you kept your window on what you had for the last problem, then you should already be set. I don't know if I mentioned it, but you can just type in 2 pi. It'll automatically figure out the decimal for you. You don't have to type it in. It'll do the calculation. All right. So now, how many answers are we getting there? 1. This one just has 1. So we just have to do second calc intersect 1 time. 1.45. Any question on that one? Very easy. Let's do this one. Right, so let's graph it and see what happens.
Are these things only the answer that we're going to get for these things? We're not going any more in depth?
We're not, yeah, for these ones, we're not going to worry about finding all of them. We're going to talk about that tomorrow. For today, that's it. 2 sine x. But once you find one of them, it's very easy to find them all. It's kind of like if I said to you, that event is going to happen every 20 minutes. All I have to do is tell you the first time it occurs, and then you can figure out every other time it's going to occur automatically. Does that make sense? Like if I said the event occurred at 11:10, and you're like, well, wait, it occurred at 11:10, it's going to occur every 20 minutes, so that means it happens at 11:30, 11:50, 12:10. It happens regularly. You just have to know the first time it happened. And that's basically what we're finding here. We're finding the first time they cross. And once you know that, the rest of them just occur regularly. It's very easy to write that. But not for today. All right, so there's 3 cosine 1/2 x and 2 sine x. How many times does it look like they cross? 3. Okay? Looks like they cross 3 times. Now, I can't really show this in the video, but if you look on the right-hand side of the board, it says 3 cosine 1/2 x equals 2 sine x. That's the problem we're doing. To do that algebraically, it took me a little while to figure out. It's tough. It uses trig identities. We haven't learned them yet. but I'm showing you can do it algebraically. We don't. We're not going to get into anything that deep in this class. We don't do that. But it is doable. All right. So does anyone need me to go through all the intersects? No? I'll do one of them now, just to do one. Okay. It says the intersection is 3.14. So what do you think that probably is? It's pi. So on the test, if you see this as a choice, like you got different choices. Each answer choice here would have 3 options because there's 3 intersects. Well, you would probably see the choice like that. So if you see a choice and it has pi in it, and your choice has a decimal, well, just change my answer that has pi to a decimal. If it was like 2 pi over 3, just do that out. 2 pi divide by 3. And when you did second calc intersect, you probably would have gotten that, 2.09. So you might have to change from pi to a decimal. All right, last one. So what's different about this one? In solving, it's almost the same thing, but it's a little different. Yeah?
Because the x is greater than negative 1.3?
Yeah, it's a greater than. The 2 cosine x is greater than something. So whenever your original problem is an inequality, your answer is not just x equals a number. It's a range. It's usually between 2 things. Right, so let's graph that and figure out how to write our answer. So 2 cosine x and negative 1.3. Same window, 0 to 2 pi. Now, this is where it's going to get a little technical about including or not including the edge of the window. Okay, let's look at that. We're looking for where the cosine function, which was in blue, is above the graph in red. Does that ever happen? Twice. Yes. It happens twice, and I'm just going to highlight where it happens. In here and here. So we have to describe those 2 sections. Well, let's start with this point. What's the x value of that point? 0. According to my thing right there, can I include 0? Yes, I can. So it's going to be from 0, including it, up to right there. How do I get that point? Intersect. So second calc intersect. Just move it a little closer, and I get 2.28. Now, does the cosine function have to be above the red line, or can it be above and equal to the red line? It has to be strictly above, so I cannot include 2.28. It had to be above. If that was an equal to, I would have put a bracket. Or I need to put, because it happens somewhere else. How do I get that point? Yep, intersect again. Second calc intersect. You already have it?
Yeah.
What is it?
4.00.
4.00. Thank you. Can I include it, or do I have to be greater than? Greater than. So I can't include it. And now, what's the edge of that window? 2 pi, or if we're going to do decimals, because we did decimals all along, 6.28. Can I include 6.28?
No.
No. There's no equal to under that thing that I just circled. 6.28. So when you have an inequality, it's not really that much more work. You still have to calculate intersects. You just write your answer as intervals between here and here and here and here. Now, if this was flipped, if that was flipped to a less than, how many intervals would you have in your answer? Jane? If that was a less than, how many sections is the blue curve below the red line? Just one. It would just be between 2.28, comma 4.00. That's where it's below. They didn't ask that, but that's where it would be. Okay. Any question on that? Okay. So that finishes up sine and cosine. Next two homeworks, today and tomorrow, those will both be in the book. Right, so it's on 346 and it just kind of jumps around a little. It's 2 through 4, 7 through 9, 15, 17, 21 to 23, 29 to 31, and 36 and 39. There's only 2 problems that you actually have to sketch anything. That's 15 and 17. So I didn't end up making graph paper. If you've got extra from the homework, you could do it on there. Otherwise, you just have to sketch 2 graphs by hand, and that's it.